So we'll start today with a short review on intermolecular forces. This is a part that you have seen on Chemistry 20. However, we will review it from the perspective of the Chemistry 30 and hydrocarbon compounds. So now in the what we have studied is that intermolecular forces are forces that keep the atoms together. So when a compound is formed, then atoms need to be kept together with that is known as the intermolecular forces. The intermolecular forces is an indication of the boiling point of the compound. So the higher intermolecular forces, the more energy is required to break that atom, and so that therefore the higher boiling point. The first and the weakest intermolecular forces is that is known as the London dispersion force. So what this force is, imagine that you have an atom and or a compound, and then you have sometimes a simple one, hydrogen. So let's say hydrogen. So then you have two atoms of hydrogens that are bonded together. So now the electrons, as they are moving, what they are doing in some moments, they will have a temporary concentration in one side, making this more negative, and therefore leaving the other side as more positive. This is very temporary, and it changes from this side to that side. So if this side is temporarily negatively charged, then in another moment the other side will be temporarily negatively charged. And those four, by doing so, what it is happening is creating a temporary dipole. By creating that temporary dipole is creating that is known as the temporary London forces. No, it's not temporary London forces, but it's that London forces which exist at every atom. Every atom or compound, it doesn't matter what, it will always have that is known as the London forces or London dispersion forces. So if in a question they are asking you to identify what type of forces do you have in that particular atom or molecule, then you, without even thinking, you have to say that it has London dispersion forces. Every molecule has London dispersion forces. And dispersion force increases with the molecule weight. So let's suppose that if we have fluorine, chlorine, bromine, iodine, then the molecular weight of them, if you check in your periodic table, will be 38 grams per mole. And then it moves to 71 grams per mole. Then bromine will be 160 grams per mole. Iodine will be 254 grams per mole. What we notice is that the boiling point and the melting point will be increase. Okay, so boiling point will be increasing. So fluorine will have the lowest boiling point. It's about 85 K. And then you go to increasing order. Chlorine is 283 and so on. In the same logic, in the same trend will be melting point as well. when we say melting point is temperature of it will follow the same trend. And this is why, because even though those forces have only London dispersion forces, those molecules have only London dispersion forces as part of their intermolecular forces, since the weight of the molecule is increased, then the boiling point will be increased. Okay. And the weight, it makes sense because you have more electrons there, therefore it is harder to break those electrons, and then that are more electrons that are forming the bonds. So it makes more sense to say, to like logical sense. Okay. The second type of forces that that molecules are experiencing as an intermolecular forces is that is known as the dipole-dipole forces. So when we see dipole-dipole forces, those are dipole-dipole forces. We very often we say DD forces. Those exist when we have those that are known as the permanent dipoles. So what a dipole is, we say that if one element has, the molecule has more power to attract the electrons more, then there is a kind of a shift of electrons. The electrons will stay longer on that atom, creating a slightly negatively charged on that element, leaving the other element as the positively charged. So let's suppose that we have this HH, then a double bond for the oxygen here. Then what do we notice is that oxygen has a stronger pull of the electrons, so therefore the electrons will stay longer there, leaving the carbon as a positively charged, quote unquote, slightly positively charged. And then this way, what they are doing, what do we notice is a permanent dipole that goes like this. When we have two molecules that have permanent dipole, the negative part of that molecule will be attracted by the positive part of the other molecule, and so then you create the chain between the molecules. Okay, so in this case, you may see that this negative dipole that oxygen is experiencing will be attracting with carbon, hydrogen, and here is double bond of the oxygen, because this is positive, a dipole is here, negative, this is positive, so positive and negative will attract each other. The dipole-dipole forces or dipole-dipole moment, what is, it's not for every molecule. We have to check and see if they exist, if the forces or the attraction that atoms are doing to the electron is the same or not, and then we'll make the judgment based on that. Dipole-dipole forces are stronger than London dispersion forces. So what do we see is that it is, if a molecule has dispersion for dipole-dipole forces, then the boiling point will be higher. Okay, so if a molecule, one molecule A, let's say molecule A has only London dispersion forces, and molecule B has London dispersion forces, which every molecule has, but has a dipole-dipole as well, then molecule B will have a higher boiling point than the molecule A. Okay? The third type of intermolecular forces that exist into the molecule is that is known as the hydrogen bond. And this is the strongest one, or hydrogen bond, hydrogen bonding. You can use both of them. This is the strongest one, and it exists only when the hydrogen is bonded directly with nitrogen, oxygen, or fluorine. If the hydrogen is there and fluorine is there, but they are not bonded directly, then hydrogen bonding doesn't exist. And in terms of the strength, the hydrogen bonding is the strongest molecular force. So if a molecule will have in her presence the hydrogen bond, that means that the molecule is has the highest boiling point. Now we'll see some examples in which we will guess and see which one is the has the highest boiling point. So let's take a look at some compounds, and we'll start with water, carbon monoxide, carbon dioxide first, and then neon, helium, and carbon monoxide. All right, so let's see first what type of forces do they have. They all will have London dispersion forces. No matter what, you will continue with, you will go straight to say, yes, London dispersion forces without even thinking about it. Sometimes London dispersion forces are known as the dispersion forces. And then we'll see, is water, does water have a dipole moment on it? Yes, it does, because if we take a look at the molecule of water, we will have what oxygen here and hydrogen here. So oxygen will have a stronger pull of the electrons, creating a dipole that goes like this being the negative and this being the delta positive. Okay, so water will have dipole forces. What about carbon dioxide? When we see the structure of carbon dioxide, we will see that it is something like this. So yes, this will create a pull of the electrons, and this will create the pull of the electrons, but since they are the same in opposite direction, so there is a no dipole forces here. You have done this into chemistry 20 in very detail. Neon doesn't have any dipole forces. Helium doesn't have any. And carbon monoxide, it doesn't have any dipole forces on it. So the only one that has the dipole forces is water. And now let's sort it. The one that will have, by the way, since hydrogen is not connected with any of them directly with, now here we have the hydrogen that is connected with, hydrogen is connected directly with water, so then therefore we'll have the hydrogen bonding here as well. Sorry. Okay, so then because hydrogen bonding is formed when hydrogen is bonded directly with either oxygen, nitrogen, or fluorine. So water has all three forces, therefore it's the strongest one, has the highest boiling point. And then we will make a judgment now between carbon monoxide and carbon dioxide, which one will have the highest boiling point, since they only have, both of them have the only London dispersion forces and no other forces. So then we will take a look at the number of electrons present on it. And the number of electrons present on it is the carbon dioxide. So therefore, 1 second. Well, I'm sorry, guys. I was having a brain fart, and I said that the carbon monoxide doesn't have a dipole-dipole force. Actually, carbon monoxide has a dipole-dipole force, and you can refer it even to the structure of the carbon monoxide and see that. Because structure of carbon monoxide is something like this, triple bond, and then we have two carbons here. So there is a dipole-dipole forces here. This is the strongly or slightly negatively charged, and this is slightly positively charged. So there is dipole-dipole forces here. So now let's sort it. We have two, one that has three forces and the other one that has two intermolecular forces. So the strongest one will be water. And then after that will be carbon monoxide. And now we have those three to choose from. And then what we will do is we will go based on the molecular weight. So the very first one after them will be carbon dioxide. And now let's see which one has the strongest molecular weight. And obviously, when you check it in your periodic table, neon will be the heavier than helium. Okay, so this will be the order of the boiling point, this water being the highest, having the highest boiling point, and helium having the lowest boiling point. This is in terms of the intermolecular forces. We will do examples in class as to which one has the highest, or what forces the compound are experiencing and why and how, as well as which one is the highest boiling point.